am Snigdha Bharadwaj. I welcome you all in my session. So, today we are going to discuss about reaction kinetics in pharmaceutics 2. So, let us get started. So, basically chemical kinetics deals with the study of reaction rates, the changes in concentration of reactants as a function of time. So, in this for following some sort of reactions, basically we need to understand the kinetics to identify or analyze the reactant types, their incompatibilities and the amount of concentration produced of a product. So, it is a quantitative relationship through the derivation of a rate law. Kinetics can reveal much about the mechanism of reaction, how the reaction is taking place between the substrates to get the desired product. So, first we will discuss about rate of reaction. So, reaction rate is the velocity of reaction to convert the reactant into its product. So, reaction may be classified according to the order of reaction, which is the number of reacting species whose concentration determines the rate at which the reaction occurs. Basically, the order of reaction may be like 0 order, first order, second order, pseudo first order, pseudo 0 order kinetics. So, it depends on the quantity or the number of species reacting with each other to get the desired product. The most important order of reaction are 0 order. Breakdown rate is independent of the concentration of any of the reactant. That means, the 0 order reaction does not depend on the concentration of the reactants present in the chemical reaction or participating in reaction. So, first order reaction is the determined one concentration term, and second order is determined the concentration of two reacting species. So, this is how we categorize order of reaction based on the components participating in the reaction. So, reaction rate is the speed at which a reaction takes place, right. So, it is how quickly a product is formed in chemical reaction. So, it is very important to identify the rate of reactions, so that we can have an idea about how much time is required to complete or to finish a particular type of reaction to get the optimum amount of finished product in the at the end of reaction. So, for example, magnesium plus Cl will give you magnesium chloride. So, manganese and chlorine are the reactants of the reaction and they produce magnesium chloride. In case of multiple steps reaction, the slowest step determines the rate of reaction. So, this is how we go for rate of reaction. So, rate of reaction can be analyzed using this formula, like decrease in concentration of reactants, time in this change take place. So, various it basically rate of reaction when we talk about. So, we are always talking in terms of time or the time of taking to get the desired product. So, rate of reaction, decrease in concentration of products, time in this changed place. So, finally, in this formula we can see the rate of reaction change in concentration of substrates into product and time taking. So, it can be presented as delta concentration and delta time. So, these are the remarks that represents the change in concentration with respect to change in time, right. So, expressing the rate reaction or rate of reaction. So, reaction rate is measured in terms of the change in concentration of reactants or products per unit time. If we say that in 1 hour, so the two reactants or substrates are getting interacted to give the desired product, like A plus B is equal to will give rise to C, that is the product. So, for the general reaction A towards B, we measure the concentration of A at T1 point and at T2 point. So, we consider it as time at one time and at other interval time, right. So, rate of change can be measured using change in concentration of A, change in time. So, concentration A2 minus A1, because the excipients or components of reaction will gradually change to the finished product. So, we need to take different time concentrations. So, that is why we are taking this formula, change in concentration of A, change in time, concentration A2 minus concentration A1, because and the time T2 minus T1 will give you this change, overall concentration change divided by T. Square bracket indicates a concentration in moles per liter. So, usually we take the concentration in moles when we analyze rate of reaction. The negative sign is used because the concentration of A is decreasing. Yes, this gives the rate a positive value. So, when we start reaction, so initially the substrate concentration is high. As the time passes, the concentration of substrate will get reduced and it will increase for the finished product, right. So, this is how it proceeds. So, in general, for the reaction A plus B will give C plus D. So, where A, B, C and D are the coefficient, the small values, the small letters represent the coefficient, and for the balanced equation the rate is expressed as. So, if you see that the previous we put that A, B, C, D in this particular reaction and we will in this particular formula equation, and then we will get this. So, rate is equal to minus 1 by A delta A t. So, it will give the value of 1 by V delta B t 1 by C delta. So, these are the coefficients of the reaction, and these are the change in concentration of A, B, C, D. Okay. So, this is how we calculate rate of reaction for particular type of reaction. So, apart from this, the collision theory and concentration has some sort of link when we analyze rate of reaction. So, with the basic principle of collision theory is that particles must collide in order to react. So, when we say that reactants are interacting with each other, that means we are saying that there must be a collision between the reactants or substrates, and after that only we can expect the reaction to occur and to give the final product. So, this theory says that particle must collide in order to react. If no collision, no reaction will be there, right. So, an increase in the concentration of reactant leads to a larger number of collisions, hence increasing rate of reaction. So, if the collision is high, the rate of reaction will be higher. The number of collision depends on the product of the number of reactant particles, not their sum. So, basically collision depends on the product and their number of reactant particles, how much particles are getting reacted with each other. It is not about that if you are taking more substrates or reactants, then the reaction rate will be higher. No, it is not, but it depends on the number of particles or particles of the reactant taking part in the collision or interacting with each others. So, you see here the number of possible collision is the product, not the sum of reactant concentration. Okay. So, you see 4 collisions are possible when we see 2 particles of A and 2 of B, right. So, if you add another substrate in the in between the reaction, the number of particles will be more which interacts. So, basically 6 collision at the time, 4 collision initially. When you add another substrate to the reaction or ongoing reaction, you will see that 9 collisions. That means, this molecule will interact with this, this and this, and the same will be done for second molecule and third molecule. So, total 9 collisions will be there to get the desired product. So, this basically represent the number of particle taking participating in the interaction or making collisions with another particle will give you the desired product, and this comes under collision theory. So, basically the reactant concentration will be affected based on this collision theory. So, factor that influence reaction rate. What are the different factors? The rate of reaction, or we can say degradation of pharmaceutical products, can be influenced. Yes, it is important to understand while we are studying reaction kinetics, that means we are it also affecting the shelf life, half life of the drug product we are using. So, basically it depends on several factors like temperature, effect of concentration, light, solvent, ionic strength, dielectric constant and catalysis. So, one by one we will discuss temperature. Generally, the speed of many reaction can be increased 2 to 3 times with each increase of 10 degree centigrade in temperature. When we talk about higher the rate of reaction, so there must be several factors to affect the rate of reaction. So, temperature is one of them, and we can expect the rate of reaction will get increased if we rise the temperature of 10 degree centigrade. So, it will increase the rate of reaction 2 to 3 times more as compared to normal one. Right. So, the effect of temperature on reaction rate is given by Arrhenius equation. This is very important rule. Then we need to identify, because we say that higher the temperature, reaction rate will be higher, but does not mean that we increase the reaction always increase the rate of reaction. Sometimes it may affect the drug component we are using, and it may degrade its quality. So, we need to analyze the appropriate temperature to be risen during the chemical reaction taking place. So, ideally we calculate the apt temperature for a particular type of reactions. So, it can be calculated or given by Arrhenius equation. So, this equation represent k is equal to a e to the power minus E a divided by R t. So, the frequency, this is the formula or the equation known as Arrhenius equation. The frequency factor A is the measure of frequency expected between the reacting molecules. The frequency factor A is the measure of frequency. The more the collision, the more the reaction rate. So, basically it can be analyzed using this Arrhenius equation. Now, in logarithm it may be expressed as follows: log k is equal to log A minus E a divided by 2.303 R t. So, the Arrhenius equation is useful when E a is in the large range of 10 to 30 kilo cal per mole. So, when we are talking about in terms of temperature, then we say that in logarithm value we have this equation to be followed, and it is basically useful when E a this coefficient, when E a is in the range of 10 to 30 kilocal per mole. If E a is only 2 to 3 kilocal per moles, as in the case of photolytic reactions, little advantage is gained from the equation. So, we particularly we use this equation for specific purposes. So, this after temperature we will talk about concentration. So, as the concentration of reacting molecule is increased, the number of collision between molecules also increased. Yes, when we gradually increase the concentration, for example, we are taking components in 1% and now we are increasing it 2%, 3%, that means the concentration of particular component is getting increased. So, we can expect the greater level of interaction or collision between the particles of the reaction. So, consequently the rate of reaction is increased. That means, if the concentration is increased, it is directly proportional to the rate of reaction. Collision between the molecules will get also increased. So, both the things will be upward direction. Now, light energy may be absorbed by certain molecule which become activated to undergo reaction, right. So, sometimes light may increase the rate of reaction. So, most visible light and UV light cause photochemical reactions. These reactions do not depend on temperature. So, light has its own significance in rising the rate of reaction, or particularly reaction kinetics. So, it will improve the rate of reaction, increase the rate of reaction, but irrespective of with the temperature, right. So, however, once the molecule have absorbed energy from light, it may collide with other molecules, raising the kinetics energy, resulting in increase in temperature. So, basically if the reactant molecules are absorbing light, so it may increase the temperature during the collisions after getting after absorbing the lights, but it does not always mean that the temperature affects the light absorbance of the reactant molecules. Basically, when the reactant molecule absorb lights, so automatically the temperature will get risen during the collision. Example, pharmaceutical compounds which undergo photochemical decomposition includes riboflavin and phenothiazines, etc. So, some drugs are susceptible to this kind of light absorbance, and it may result in the decomposition of the active pharmaceutical ingredients during the reactions. Now, we will talk about solvent. The quantitative relationship between the reaction rate and the solubility of reactants and products is given by equation. So, there is a quantitative relationship between the reaction rate and the solubility of reactions and the resultant product, because the more the particle or reactants will get solubilized within the system, they will give the optimum value of the product or end product. So, this can be analyzed using this equation: log K is equal to log K naught plus V by 2.302 R dot 1 by T delta S A, S B and S asterisk. So, this is how we established the relationship, how much reactants are present in the equation and how much are in solubilized form, because the unsolubilized form will not give the desired product. First the reactant must be in solubilized form to get the desired product. In other terms, a polar solvent tend to increase the rate of those reaction in which product form is more polar than the reactant. So, generally when we use this equation, we say that polar solvents increases the rate of reaction, particularly for those which are giving the polar end product more than the reactants we are taking at the starting of the reaction. If the products are less polar, then it tends to decrease the rate of such reactions. So, generally if products are not non-polar, it decreases the rate of such reactions, right. So, polarity is the thing which is affecting the rate of reaction. Commonly used non-aqueous solvents for drugs include ethanol, glycerol and vegetable sol. So, all these non-polar solvents generally have lower rate of reaction as compared to polar one. After this solvent relationship, ionic strength is also a factor which influence the rate of reaction. The effect of ionic strength of a solution and its rate of degradation may be expressed as follows: log K is equal to log K naught plus 1.02 Z A Z B V mu. So, this is the equation generally used for identifying the ionic strength of the reactant molecules participating in reaction. According to the above equation, an increase in the ionic strength of solution would tend to decrease the rate of reaction. So, basically if the ionic strength of the solution is higher, then the rate of reaction will be lower. This is because the interaction bonding among the particles are very high, and it will restrict the molecules intermolecules to participate in the collisions with other molecules to give the to form the end product. So, sometimes if the ionic strength is high in the solution, that means the particular reactant is not very suitable for giving the end product, because the strength is very high. So, the collision will be higher, but due to that strength it will not convert into the final product. So, basically this is the inversely proportional, the rate of reaction is inversely proportional to the ionic strength. That is why it's represent the ionic, if the ionic strength is higher, the rate of reaction will be lower. Now, after ionic strength, dielectric constant of solvent. So, the dielectric constant or relative permeability, we can say it, of solvent has a significant effect on the rate of reaction. It has dielectric constant of an ionic reaction is given by this formula, log K. Basically, it is a rate of reaction log K epsilon is equal to infinite minus K Z A B divided by epsilon. So, this equation represents the relationship of dielectric of constant and the rate of reaction. If the reacting ions are of opposite charges, right, for example, plus and minus, then it will result in increased rate of reaction, because affinity will be higher to get interacted and the rate of reaction will be increased, right. If ions of similar charges involved in reaction, it will decrease the rate of reaction, because opposite charges attracts more as compared to similar charges. So, there is a inverse relationship of the rate of reaction. So, opposite charges have the directly proportional relationship with the rate of reaction, that is why it is a upward direction, and similar charges will give the lesser rate of reaction or influence in a inverse manner. Now, after this, catalysis. So, a catalyst is defined as a substance which increase or decrease the rate of reaction without itself being altered chemically. So, basically catalysis or catalysts are those compounds which enhance the reaction rate without affecting or without directly participating in the chemical reaction, but they enhance the rate of reaction. So, most of the chemical reactions are catalyzed in the presence of catalysts, generally enzymes, right. So, these enhanced the rate of reaction by providing an alternative course for chemical reaction. So, basically catalysis or catalyst have the direct proportional relationship with the rate of reaction. We said that if we add catalyst to a particular reaction, it will enhance the rate of reaction without being altered in the ongoing reactions. So, once we will take the highlights from starting what we have discussed in this particular lecture. So, basically we have covered the chemical kinetics, because this lecture is basically relevant to the basic understandings of chemical kinetics. So, basically chemical kinetics or reaction rate studies are important to and identify the concentration change, because while understanding the change in concentration, we are directly talking about the product formation at the end of chemical reaction. So, these chemical kinetics are the quantitative relationships through derivation of a rate law. So, basically it is also tells you about the mechanism of reaction. After this, the rate of reaction. What is the rate of reaction? It is a speed or velocity of a reaction to convert the reactants into its product. Fine. So, reaction rate, this is how we identify rate of reaction using 0 order, first order, second order, pseudo orders. So, we have ample of reaction orders depending on the constituents or number of reactant participating in the reaction. So, these are the formula through which we can express the rate of reaction mathematically. Now, expressing the reaction rate. So, depending on the constituents taking part in the reaction with respect to time, we can calculate using this particular equation, change in concentration of the constituent or reactant divided by change in time. After that, collision theory. Collision means the particles must collide in order to react. If it is not colliding, that means they are not going to produce the final product. So, collision depends on the number of particles interacting with each other, not the sum, right. So, if we add another particle, so the number of collision with each other will get increased. So, these are several factors which influence the reaction rate. Temperature has directly proportional relationship with the rate of reaction, effect of concentration, light, solvent, ionic strength, dielectric constant, catalysis. So, they have different effect on the rate of reaction. Concentration has directly proportional rate of relationship with the rate of reactions. Light also increases, in some cases increases, it is variable basically. So, the light sensitive particles generally decompose during the absorption of UV or some sort of radiations. Solvent has polar solvents has more rate of reaction as compared to non-polar. Ionic strength may get the inverse effect with the rate of reaction. Dielectric constant, basically opposite charges will give you the higher rate of reaction in the processing, and similar charges will get reduced rate of reaction. Catalysis always give the higher or promotes the rate of reaction. So, these are several factors. So, these are references. I hope you understand the basic consideration or general consideration of the reaction kinetics, why it is important. So, we will be continuing this topic in our next session. So, till then, take care, stay safe, thank you.